So we are looking at chapter 2, 2.3, composition of functions. Sound exciting. So we are going to find the composition of two functions and the domain of the composition. So when you have compositions of function, the notation is F, and you see the little circle, that means composed of. It's not multiplication or anything like that. It means composed of. So this little circle they give you, composed of. So when I look here, composite function, when you read that, that's F composed of G. And then when I look here, I can rewrite F composed of G of X as equal to F of G of X. What we are doing with composition function, we are putting one function inside of another function. The functions are always given to you, so you don't have to memorize anything. So what we want to do here, I have f of x is equal to 2x minus 5, and g of x is equal to x squared minus 3x plus 8. And they want me to find f composed of g of x, and then g composed of f of x. So what it means is that I'm going to input g into f. So g is going to go, the g function is going to go inside of your f function. So my f is equal to 2x minus 5. So now I just input g into there. Now f is pregnant with g. So you put g, that whole function, after the equal sign into f. So once I do that, every I see x, so this x right here is going to go away. And I'm going to stick my g right in there, just stick it right in there. So we just eliminate this x, it goes away. We put the g in there, and now we can multiply 2x squared minus 6x plus 16 minus 5. Now you can see if you have the like terms that you can combine. I can combine 16 and negative 5. So I get 2x squared negative 6x plus 11. And you can leave it just like this. You don't have to factor or anything. It stays just like this. So f composed of g of x is 2x squared minus 6x plus 11. Composed of, so the little dot means little circle, not a dot. Little tiny little circle look like fog. So now the second part here I need to input F into G. So G is x squared minus 3x plus 8. And then I want to put F into there. So now G is pregnant with F. Everywhere I see X, I always write terrible threes. I'm going to write 2x minus 5 because this is my input. Now here you want to FOIL that whole entire thing out. So when I get that, I get 4x squared minus 10x minus 10x plus 25. And that yields 4x squared minus 20x plus 25. And then the second part here, I get negative 6x plus 15 plus 8. Now I have to combine anything as like. So I have to do, let's see, I have a 4x squared. There's nothing like with that, but negative 26x plus 48. 25 plus 15, 40 plus 8 is 48. So just let me know if you have any questions. Moving on to the next problem. And this one you can do two ways. And I'm going to do it the way that I think is easier. But if you have a problem with that way, I can do it another way if anyone wants to see it. So they want me to find F composed of G of 7 and G composed of F of 7. Now I have the same functions. I could just use the first one, but I want to break it down a different way as a new problem. So with this F composed of G of 7, we want to work on the backwards. We want to put 7 into G, and then once we get that answer, we want to put that number back into F. So once there's a number as your input, and we want to work backwards. So I want to put 7 into G, and then take that number and put that number back into F. So everywhere I see X, I am going to write 7. I don't know, I am speaking. I don't know why it's not working. Can anyone else hear me? Someone say yes. Allison, can you hear me? Well, that's probably like the connection. Okay. So I'm going to try to talk louder and closer because maybe it's the connection. So I am going to, everywhere I see X, I'm going to replace it with 7. So now I have 49 minus 21 plus 8. 49 minus 21 plus 8 is, do the math, it came back 36. So G of 7 is 36. So once we get G of 7 is 36, we replace the 36. Well, we input the 36 into the F. So everywhere I have X, I replace it with 36. 72 minus 5, 67. Any questions on that one? So now we can look at G composed of F7. Let's say I do this one. Should I do this one a different way? Are you guys okay with the way I did example the first part, F composed of G, putting the 7 into G, then putting the 7 into F? Because sometimes what you can do is first, okay, because first what you can do is you can put G into F like we did in problem the first part A, and then substituting the 7 back in. But I like it this way because you just do the 7 into F and that number into whatever. Well, the reverse for the first part. So now let's just look at this one. G composed of F plus 7. So I want to put 7 into F first. Everywhere I see X, I'm writing 7. So 2 times 7 is 14 minus 5, which is 9. Now I have to find G of 9. So 81 minus 27 plus 8, 54 plus 8, 62. So if you were doing this in my math lab, your final answer would be 62. And for this one, your final answer will be 67. But you have to get each piece so you can lead it up to your final answer. So remember, we work backwards. So 7 goes into F. And once you find F, F goes into G. So we are given our two functions. They want me to find F composed of G of 4. So what is the first step that I should do? Any ideas on the first step that I should do? I give you a hint. What should I do with this 4? Plug 4 into G, yes. So plug 4 into G. So I get 16 minus 5. So 4 squared 16 minus 5, then 11. Now what do I do? Anybody got any clever ideas? Allison is the only one that came to class. So I need to plug. Yes, John is here also. Plug 11 into F. $22 minus 1, 21. So F composed of G of 4 is 21. Okay, moving on. So you have to do a lot of these because you want to make sure you get these right because they're going to be a lot on the test. I have 2 functions given to me. Now they give me an H. So H composed of F of 1. It's composed of F of 1. So working backwards, I put 1 into F. And multiply, I get 2 plus 3, 5. F of 1 is 5. So now I add 5 and plug it back in for H. And 5 cubed is, that should be something easy on top of your head. 125. So H composed of F of 1 is 125. Now sometimes we can put a function inside of itself. Well, like sometimes biology stuff or something like that. You put a function inside of a function. Sounds technical. But we need to put f inside of f. So if you get an f, you get a double. So first we need to find f of -1. So we still do it the same way. You're working backwards. F of -1, we find that. So everywhere I see x, I write a -1. A -1 cubed would give me a -1. So now we take it and put it back into f. So find that, and then we go backwards, and then we put it back into f. You probably thinking, what the heck is going on? But then you get -1. So f composed of f of -1 is -1. Now that was fun, right? If you having fun, right? That was a fun one. So f, we put -1 into f. Yes, you have to do it because even you have to find f of -1. You're working backwards, so it's going in itself. So you have to do the steps exactly if you had a different function. So you put you put -1 into f and then -1 back into f. So you double dip. F is greedy, so it doesn't want to share. So you go back, you put -1 into f, and then the results of that. And if -1, it came out to be -1 just because of the number. If you square it, cube it, then you get -1. But if the number was different, the answer would be different. So it probably wouldn't come back at -1. It just look weird because, once you square a 1, it's going to, be 1. So that's why that came out like that. So now we're going to look at the same type of problems, but we want to know the domain. And remember, I told you the domain never goes away. Yeah, we are doomed with the domain. So first, I'm going to find f composed of g and g composed of f. So they gave me this. F of x is equal to the square root of x. G of x is x minus 3. So f, my output is radical x. So I need to put the function g into f. So replace, so this x, I'm going to replace with minus 3. So f composed of g of x is radical x minus 3. And there's nothing you can do with that. Just leave it like that. Whee! So now g composed of f of x. The f function is going to go inside the g. G is x minus 3. And the f is radical x. So I'm taking out this x and replacing it with the radical x minus 3. Now, a lot of students get this one wrong because they start adding the function out of it. Okay, yeah, so what we did, because the radical throws people off, but it's the same thing we input in for the first one here, f composed of g of x. G is going to go inside of f. F is a radical x. So we take the x away because x is just a placeholder. So we just eliminate the x and replace it with g for f composed of g of x. So g goes into the f function. Everything that's after the equal sign goes into your f function. Therefore, x minus 3 goes into your function. The x is not there anymore. You replace the x with the x minus 3. And so now you radical x minus 3. So g composed of f of x, the f function is inside of g. So f of x, the f function, everything after the equal sign is a radical x. And now for g, you have x minus 3. So we want to eliminate this x, get rid of it, and replace it with the radical x. And now you have radical x minus 3. Did that help, Allison? Okay, so the next one, they probably want me to find the domain. So f composed of g of x was what, radical x minus 3. So this is just taking it from the part A. So they want the domain of this. And I think g composed of f was x minus 3. So the funny thing, the domain is all the numbers that x can be. And we always want to exclude the numbers that x cannot be. So we want to find the function of each function first. So here you would have, first you would have x is greater than or equal to 0. And then bracket 0, comma, positive infinity for your f function. And for your g function, it's not a fraction, it's not a radical, so therefore it's all real numbers. So when you find in the domain of composition functions, you just got to make sure you can account both domain because they are both part of the composition. But it's still just looking at what your answer was. So in the first part, when I found f was a g of x got radical x minus 3. So what I can do is I just take what's inside of the radical and have that greater than or equal to 0, and then solve for x. So your domain is x is greater than or equal to 3. You just write it in interval notation. And so it's like the radical supersedes the all real number. So it takes everything in account. So your domain would be x is greater than or equal to 3. And then your integral notation is with 3 comma infinity. So with the second problem, with the second part, wait, I have a question. Why is x3 in a radical? Because from the first problem I was in there. This part A, let's see, f composed of g of x gave me, and when I put the g function inside of the f, I got x minus 3. So I did that in the first part A. And now I just needed to find the domain of that. And then the same here. When I put f into g, I got radical x minus 3. Now the domain of this one, for g composed of f, I have x, radical x minus 3. I have to take what's in this radical right here and set that greater than or equal to 0. So x has to be greater than or equal to 0 for your domain. So I write bracket 0, comma, infinity. Your integral notation, don't do anything to the negative 3. No, because negative 3 is our, that part is going to be our real number. So the radical is the part that you have to concentrate on, because you know you need to exclude any not any negative numbers. So we just need to make sure we put that part in. So that's why we don't do anything with the 3, because the radical is what is going to give me something that I don't want. So whenever you have the radical, if you have the radical in the beginning, at the end, or any time, you just take that radical part and determine your domain. So this one here, again, we're going to find f composed of g of x, g composed of f, and the domain of each. It's a domain composition. The first one, f composed of g of x, we are going to put g inside of f. So the output for f is plus 1. And if I g in there, I'm going to erase this. Now if I stick g in here, x minus 1 goes in there. The output is plus 1. So I'm replacing this x with x minus 1. Now I really don't need these parentheses. I just put that here to show you that I need to replace that. So now I have x minus 1 plus 1 just gives me x. Now if I look here at f of x is equal to x plus 1, the domain for that is our real numbers, not a fraction. It's not a radical. So therefore, it's all real numbers. When I look at the function g of x, it's not a fraction. It's not a radical, so it's all real numbers. When I look at my final answer of x, that's not a fraction, it's not a radical, so the domain of that is all real numbers. I don't have any radical that's included in there, or any fraction. So it's going to be all real numbers. So G composed of f of x. I am putting f into G. G is x minus 1. So now f will go inside of G. And I put in parentheses to let you know that we got rid of this x and we are replacing it with x plus 1. You can get rid of the parentheses now. And then we have x plus 1 minus 1 and x. So the domain is going to be what? Anyone knows? So the function f of x is all real numbers. G of x is all real numbers. G composed of f of x is not a radical. It's not a fraction. So it's all real numbers. So any questions on this one? You just input in one function into another one, and then your final answer for that, you just find a domain for that. Yeah, it's basically what we did first, and then we just added on the domain part. So you just input in G into F and then F into G, yes. No, they gave us a fraction. I know it's a lot, but it's important to practice this and make sure you get it. We want to find F composed of G of X, of course, and then G composed of F. So F, and then we put in G inside of F. So G is our input. Our output is 3x minus 6. So this is my G of X. And I'm going to write that. Now it looks crazy, but it's actually a good problem because this 3 multiplying this fraction, when you look at this denominator, if I make 3, if I write 3 over 1, I can cancel this 3 that's in this numerator with this 3 that's in this denominator. So now I have x plus 6 minus 6, and I get x. So f composed of g of x is x. And the domain, since there's no fraction, no radical, it's going to be all real numbers. So we just have f composed of g of x. So f composed of g of x, we put g into f, and then we came up with x as our final answer, and the domain of that is all real numbers. So now we have to do g composed of f of x. So I need to put the f function inside of g. 3x minus 6. So we only replacing the x with 3x minus 6. So this x goes away and we write 3x minus 6. Now I need to fix up the top, clear up my top. So I get 3x over 3 because these 6, negative 6 and positive 6, that cancel out. So now I can reduce 3 over 3, cancels out. So this is so x g composed of f of x is x, and the domain for that is our real numbers. Questions? And that's all I have for compositions of functions. So you can do the My Math Lab homework with ease now. I'm going to stop the recording, but I will still be in the classroom.